Hey guys, today we're going to be reviewing systems of inequalities and word problems that go along with that. So let's just review real quick what a system of inequalities is. Well, basically, it is when two inequalities are working together to find a common solution. Okay, so if we are asked, which is what we're being asked in this first question, to identify ordered pairs that are solutions to a system of linear inequalities, we are looking for the ordered pair that make both inequalities true. If it does not work for even one of these inequalities, it is not a solution to the system as a whole. So let's go through them one by one, okay? What do we do when we're given a set of ordered pairs? Well, if we don't really have graph paper, one thing that we can do is we can plug them in, test them out, okay? So let's take a look at number 1, 0, 3. If we plug this into the first equation, we get 3, which is my y value, less than 2 times 0 plus 2. 2 times 0 is 0. So we get 3 is less than 2. We know that is a false statement. So since it is a false statement, we don't even need to test the second one because immediately we know that this is not a possibility. Okay, so let's try number 2. 2, 0. So we're going to plug that in. 0 is less than 2 times 2 plus 2. 0 is less than 4 plus 2, which is 6. Is 0 less than 6? And that is true. Okay, so we know that it works for the first inequality, but in order for it to work for the entire system, we need to plug it into both. Okay, so when I plug it into the second one, I get 0 is greater than minus, and we're substituting in a 2, minus 1. So minus 2 minus 1 is minus 3. So is 0 greater than or equal to a minus 3? And the answer is yes. Okay, so number 2 definitely works for both. Okay, now it never hurts to check the rest of them. Okay, we want to check to see if the other two work, just in case we made a calculation mistake. So number 3, we're going to test negative 1, 0. So 0 is less than 2 times negative 1 plus 2. 0 is less than negative 2 plus 2, which is 0. So we have this 0 is less than 0. Well, it is impossible for 0 to be less than 0 because it is equal to 0. So the only way for this to be true would be if there was that symbol underneath, and there's not. So this we can rule out right away. And number 4, just to double check, minus 4 has to be less than 2 times minus 1 plus 2. So minus 4 is less than minus 2 plus 2, which is 0. That's an accurate statement, so let's just double check the second one. Minus 4 is greater than or equal to minus a minus 1, minus 1. So minus 4 is greater than or equal to, and that would give me 1 minus 1 is 0. We see that that is not true, so this also verifies that number 2 is the ordered pair that is in the solution set. Okay, so this is what you can do if you don't have a graph. But it's also important to be able to graph a system of inequalities on a coordinate plane itself. So how do we do this? Well, first we want to make it so that it's graphable. Typically, we do that by making our equations in y equals format. So considering these are both linear, we're going to have to rearrange our terms so that we get it into a y equals mx plus b format, but obviously not equals. So we take x plus 3y is greater than or equal to 6. So I want to isolate the y. So I'm going to move over my x. I get 3y is equal, greater than or equal to minus x plus 6, divide by 3. And I get y is greater than or equal to, so I get minus 1/3 x. And then remember, this goes to both of them, plus 2. Okay? And just to be color-coded, right? It's always good to color-code if you can possibly do so. If not, you want to make sure you definitely label your equations. But I'm going to say the second one's going to be our blue equation. Okay, so for the blue inequality, it would be 2x minus 3y greater than 3. subtract 2x from both sides, minus 3y greater than minus 2x plus 3. Now, when I divide by this negative 3, we cannot forget that dividing by a negative value flips my inequality symbol. So that greater than symbol becomes a less than symbol. That's going to be key in identifying your solutions. Okay, if you forget to do that, the whole thing will not be correct. Okay, so let's graph them. Let's start with the y. Now, since this is linear, I don't have to jump right to my calculator. I can plot this by finding my y-intercept of 2 and then plotting my slope of down 1 over 3, right? Because that's what that slope's in. Down 1 over 3, down 1 over 3, and then reverse. Up 1 over 3. Up 1 over 3, up 1 over 3. Okay, so now with inequalities, the first thing, once you've plotted the points, you have to decide if it is solid or dashed. Now, anything with an or equal to sign is going to be a solid line. Okay, anything with a strict inequality is going to be dashed. So, because this is a greater than or equal to, I'm going to connect these points solidly all the way through. Now, the last thing I need to do is worry about my shading. So one way to test the shading is to use what's called a test point. Okay, typically a test point, unless it goes through that, is going to be 0, 0, 1, 1, 2, 2, something easy to calculate and not so easy to make mistakes. So when I use my test point, basically I plug it in, evaluate fully, and decide, is this a true statement? So is 0 greater than or equal to 2? It is not. It is false. So if that is the case, we are going to shade on the opposite side of the line that the point is located. So 0, 0 is on this side, which means we're going to be shading on that side. So I'm going to get my red shading, and I'm going to shade everything that is above the line. Now, if you're able to see above the line right away, that you can skip the test point part, but we don't want to make any silly mistakes. Okay, let me just get rid of this and this. Okay, so now for the blue line, going to do the same thing. Identify the y-intercept of -1 and count the slope up 2 over 3. Up 2 over 3. Oops. 2 over 3, up 2 over 3, and down 2, 1, 2, 3, 1, 2, 3, 1, 2, 3. So now we decide, is it solid or is it dashed? Well, it is a strict inequality, so that is going to be dashed. So 1, 2, so I make sure that my line is not connected. Okay, and now we use a test point to decide which side to shade. So again, I'm going to use 0, 0 because it's clearly not on the boundary line. So 2/3 times 0 minus 1 is 0 less than -1. And the answer is no. -1 is clearly less than 0. So that means I'm going to shade on the opposite side of the line, which is this guy right here. Okay, so we color it all in. And so now the last part of graphing an inequality is to identify the solution area, and typically we label that solution area with an S. So my solution area is the overlapping region where there is both red and blue shading. So that is this little triangle here, and of course this will continue extending, and the solution set will always be between those two lines. Now, there is a possibility to graph inequalities on the calculator. So just so we can use this to our advantage, in the applications button, which is on your calculator, 2 buttons below the mode, there is an app called Inequals. Now, hopefully your calculator has this app. And if you enable this app by pressing app button and pressing enter on Inequals, you are able to change the symbol of your graph to your inequality symbol. So you can do less than, you could do greater than, you can do less than or equal to, etc. Okay, and you do that by highlighting over the box, right? Using your left and right arrows to scroll through and find the appropriate symbol, okay? And then just type in the inequalities as you see them. So this is what it would look like if you plotted this with the in equals app on your calculator. Now, what is the benefit of this? Well, two things. A, when you go to your table, it'll give you all the boundary points for each individual line that you can plot, so you don't have to count up 1 over 2, etc. Second thing, it gives you a heads up about what side to shade. Now, my colors are backwards, but it is the same general picture that you see up here, where the solution area is right here. And the other benefit is that it does tell you if it is solid or dashed. Notice this above 1, is a solid line, whereas this below 1, like we have up there, is dashed. So if you have any questions, this calculator application can be of great use to you. So how do we interpret these solution points? Well, basically any points that are in this overlapping area is going to be considered a solution to the system of inequalities. But we have to be careful, because we have some situations where it might look like it's in a solution area, but it's actually not. So let's take a look at these points. It says, which ordered pair is in the solution set of the system of inequalities below? So the first point is minus 2, 1, 2, minus 1. So that is the point of intersection of the two boundary lines. Now the question is, does that make it a solution? And in this case, it does not. Now, why doesn't it? Well, if a point falls on a dashed line like it does here, it would not be considered a solution to that particular inequality. So although it is a solution to the solid line, it is not a solution to the dashed line. So the choice number 1 is not a solution set. So what about negative 2, 2 up here? Is that clearly in the solution area? And the answer is yes, right? So it is in that overlapping area where both shaded regions are. So it's looking like negative 2, comma 2 is going to be our answer. But let's check the other ones. So minus 2 and minus 4. 1, 2, 3, 4. Well, that is in an area where there is absolutely no shading at all. So hopefully there's no doubt that that is not a solution point. And then last but not least, 2, 1, 2, comma negative 2, 1, 2. Now that is, again, only a solution for one of our inequalities because it's only in the solution area for one of those inequalities. So the answer here is negative 2, comma 2. Okay. And last but not least, the system of inequalities word problems. Okay, so the important part here is being able to convert the words to equations and then graph them appropriately. So it says, the Real Good Cinema is conducting a mathematical study. In its theater, there are 200 seats. Adult tickets cost $12.50 and child tickets cost $6.25. The goal is to sell at least $1,500 worth of tickets. Write a system of inequalities that can be used to find the possible combinations of adult tickets, which is our X value, and child tickets, which is our Y value. Okay, so on the X value here is adult tickets. Okay, on our Y value here, it is child's tickets. Okay, it's important to use the variables that they define for us. So what are our two situations we're writing for? Well, we have seats and we have money. Okay, well, if X plus Y equal the total number of tickets sold, that will mean that is the total number of people taking up seats, right? So that means X plus Y has to be less than or equal to 200. Okay, and the reason for that is because there are only 200 seats. We are capped at 200. We cannot have 201 people coming into this theater. So the other equation we have to worry about is the $1,500, at least $1,500 worth of tickets. So we need to sell at least that. So that means whatever we sell should really be greater than that amount. Okay, so how do we find the amount? Well, we have to add up the money we make from adult tickets. So $12.50 times X is the number we make from adult tickets, plus $6.25 times child tickets. And all of that has to be greater than or equal to 1,500. Okay, so those are the two equations, inequalities that we are working with here. These would help us identify what satisfies the cinemas goal. So the next part of the question says, graph the solution to the system of inequalities on the axis below. Now, when we have these really tricky numbers, these really big numbers, I tend to use my intercept method. Okay, the intercept method basically states if you graph the x-intercept and the y-intercept and use a ruler, you can connect those 2 points to create the line. So my x-intercept is the point where y is equal to 0. Okay, so my x-intercept for that first equation is 200. So that's right here at 200, and since x is going to be less than or equal to 200, we're actually going to be shading in that direction. So I tend to write a little arrow in the direction I'm going to be shading. Now, what about my y-intercept? Well, that is when x is equal to 0. So we get, y is less than or equal to 200. So that is my y-intercept here. And again, I'm shading below that. So now these are the two intercepts for this particular point. So I can connect those two, and it will give me the approximate value. I can also shade, right? Since they're both pointing below, I can shade everything below the line, which I'm going to do right now. Okay. Okay, so now let's do the money equation. We have to find our x-intercept, $12.50 plus 6.25 times 0 is greater than or equal 1,500. Well, this time 0 goes away, and I can divide out this $12.50 on both sides to get x is greater than or equal to 1,500 divided by 1250, 120. So x is going to be greater than 120. So I plot that point on my x-axis, and it goes up. And then we do the y-intercept. So 1250 times 0 plus 6.25y greater than or equal to 1,500. Anything times 0 goes away. Divide both sides by 625. And we get y is greater than or equal to 240. So 240 and up. So now I can connect those two intercepts together. Okay. And I know that I'm shading above this. So I'm going to be shading here. So everything above it, which is right here. So there is my graph. It also says to label the solution area with an S. So my solution area, again, is the place where we overlap. So that's this area right here. Okay, so now the last part of the question asks, Marta claims that selling 30 adult tickets and 80 child tickets will result in meeting the cinema's goal. Is she correct or incorrect? Well, we're looking for the point adult, X, and child, Y, 30, 80. Is that going to meet the goal? And the answer is no, because it is not in the shaded region. Okay, it will not satisfy this red inequality that I have graphed.